Okay, so here we're going to do question 4 from the Physics 115 September 15th tutorial questions. And the question is looking at the mean value of cosine squared over a certain number of cycles of an electromagnetic wave. So the first part of the question is quite simple. It asks us to sketch both cosine theta and cosine squared theta over a certain number of cycles, 2 or 3 cycles it says. So here is our graph of cosine theta, and hopefully you can all do these by memory, but just in case you can't, I'm going to set up plus and minus 1, and we got cosine, so it's going to do something like this, oscillating nice and steadily between 1 and minus 1, and that value there is going to be 2 pi radians, that value there is going to be 4 pi, and so on. Hopefully that looks pretty similar. Now, a lot of people are less familiar with cosine squared, but it's pretty obvious what it's going to look like. You know that it's forbidden to be minus 1 because we're not dealing with complex numbers here, so you know the maximum it's going to have is still positive 1. So what cosine squared theta actually looks like is pretty much exactly the same thing. It's just all shifted up slightly, kind of squashed in half to be positive. So it starts at 1, goes down to 0, and it does this. Again, this is, oops, sorry, that one there is 2 pi. The one I just marked out was pi. So that's our first part of the question. Oh, sorry, just the last part of that was figure out what the average value is going to be for both of these. So if you imagine the average of this over an entire cycle from there to there, on average it's actually right in the middle here, because there's about half of it above, about half of it below, well in fact exactly half above and half below, so therefore the average value of cosine theta is going to be 0. Cosine squared theta though isn't going to be 0, is it? Because it's never dipping below 0, so it's never going to subtract off. It's going to have a positive number. The question is, what is it going to be? And because it's saying a rough estimate, I'm going to guess it's probably going to be somewhere in the middle around there. I'm going to guess that it is, in fact, a half. We'll come back to that. I'm probably wrong. The second part of the question is asking you to calculate the average by integrating it over a certain interval of theta and then dividing your answer by this interval. So to actually check our answers, all we need to do is start off with something like this. 1 on 2 pi integral between 0 and 2 pi cosine theta d theta. And this is, if you're not familiar with, this is functionally exactly the same as calculating an average. We're just adding all the little bits up together and then dividing by the total. Now, if we want to do this integration, that's actually really simple. The integral of cosine theta is sine theta, so I'm going to write this as 1 on 2 pi sine theta evaluated at 2 pi and 0. Sine theta at 0 is 0, sine theta at 2 pi is also 0, so 0 minus 0 is going to give us 0. For the second bit, we've been asked to do the same thing but for cosine squared theta. So 1 on 2 pi, integral between 0 and 2 pi, cosine squared theta d theta. And we've also been given the trigonometric identity stating that cosine squared theta, right down here, cosine squared theta equals 1 on 2, 1 plus cosine 2 theta. And this is really nice because it allows us not to have to integrate that, even though that's not too hard. So if we replace that, the half is going to come out here, and we're going to end up with a quarter. Pi 2 pi 0 bracket 1 plus cosine 2 theta d theta, and we can just integrate that. So we're going to integrate that and we're going to get, remember our 1 on 4 pi, integrating that we're going to get the integral of this, which is just theta, plus the integral of cosine 2 theta is sine 2 theta divided by 2, so it's divided by the differential of what's inside that, evaluated at both 2 pi and 0. So final step now is we're going to have 1 on 4 pi times this evaluated at 2 pi. So sine at 2 times 2 pi, so sine at 4 pi is 0, so that term goes away. And in fact, that's exactly the same when we evaluate it at 0. That term goes away as well. This one, however, doesn't. So we're going to end up with a 2 pi here and a 0 from the second term. So this is just going to be 2 pi, and we're going to get 2 pi over pi, 2 cancelled with 4 equals precisely a half.